Everybody, here's the, I'm going to go over all the answers to the homework on graphing logs. Okay. Just remember that the basic shape, all right, for a log graph is instead of with an exponential, remember they're inverses of each other. So an exponential, we have a horizontal asymptote. In a log graph, we have a vertical asymptote. Okay. In an exponential, 0, 1 was a point. Well, we just changed the x's and the y's. 1, 0 is always a point. And then you always have, so it's always going to be 1, 0. All right. And then the other used to be 1, the base. Well, now it's going to be the base, 1. So if it was like log base 2 of x, then it would be at 2, 1. And the general thing looks like that. All right. All the other transformations, we're going to do exactly the same. All right. So in number 1, all right, the only transformation we have is we have a number in the parentheses after the log. So this is going to be a horizontal slide. Okay. And you set this equal to 0. So we're going to move this. It's a positive 3. So it means we're going to move it 3 to the right. Okay. With exponentials, it was the number out here by itself that moved the asymptote. Now, since it's a vertical, it's anything that moves it left or right. So that means my vertical asymptote is now going to be at x equals 3. All right. Normally at 1, 0, we move that 3 to the right. So now I'm at 4, 0. And, all right. Now it's a natural log. So what's my base? My base is an e. Whenever it's a natural log, all right, my base is an e. All right. Natural log is base e, which is 2.718. Okay. So normally I am at, it's remember the base. So that's e. So that's in here somewhere, right? So that's, over here, 2.718. So 3, it's going to be like 5.7. So 1, 2, 3, 4, 5, 6, somewhere right around there. Let me use a different color. So it's like here and here. And you just want to make sure that you label these points. All right. So this is 4, 0. And this is E plus 3, 1. Okay. Now my domain, all right. Now my domain for exponentials was always negative infinity to infinity, which means my range is always for logs is always going to be negative infinity to infinity. The domain is either going to be negative infinity to the horizontal asymptote or horizontal asymptote to infinity. Since on the right side, it is going to be the horizontal. I'm sorry, the vertical asymptote. I keep saying that. Vertical asymptote. The vertical asymptote is 3 to infinity. There we go. All right. There's number 1. Number 2. All right. We have a log. We have base 2. All right. We have a base 2, which means our points that we're going to be starting with are 1, 0 and 2, 1. All right. 1, 0, 2, 1. Those are the points. Now, what do I have going on here? I have this negative in front. That's a vertical flip. All right. That changes the signs of the y's. All right. Nothing with the x, no numbers here. This means this negative 2 means I'm going to move this down 2. All right. Since there's nothing horizontal left or right, that means my vertical asymptote is still going to be at 0. All right. Still going to be at 0. All right. Now, 1, 0. Vertical flip means you change the y-axis, you flip over the x-axis, you change the y coordinate. You cannot, doesn't do anything. 1, 0, you just stay at 1, 0. So that means 1, 0, just move down 2. So I'm now at 1, -2. And normally I would be at 2, 1. A vertical flip makes me at 2, -1. But then I got to move down 2. So I'm like right here at 2, -3. All right. And it looks like that. All right. So this point is 1, -2. This point is 2, -3. The range is negative infinity to infinity. The domain is going to be my vertical asymptote, which is 0 to infinity. All right. Number 3, back to base E. All right. So 1, 0, and E, 1. Those are the points you start off with. Okay. That's what would the basic shape would be. Those are the points you got to move around. So here we're going to move 1 to the right. And this we're going to move down 2. All right. No flipping going on. So remember, this in here affects the vertical asymptote. So 1 to the right means we are now at a vertical asymptote at 1. All right. 2, 3, 4. And move this down a couple. Okay. So in order for all right, sorry guys, something happened on my something lost connection, and I don't know. So hopefully we're all good now. All right. So we have 1 to the right, which means that's why the vertical asymptote is at 1 now. Okay. And we'll have to move it down 2. So our points, because this is base E, natural log, is 1, 0, E, 1. So normally I'd be at 1, 0. But now I have to move 1 to the right and down 2. All right. So that's at 2, -2. All right. So 2, -2. All right, my other point is already E, 1. E is 2.718, 1. I'm going to move it to the right 1, and then I'm going to move down 2. And my graph will look like that. Now, this point is normally E, 1. It's now E plus 1, because I added 1 to the x. We slid to the right and moved it down to 1 minus 2 is -1. All right, E plus 1, so it's roughly 3.718, so 1, 2, 3. See, it's in between 3 and 4. It doesn't be exact, as long as it's in between the two things, or as long as it's labeled, it all works. All right, the range, as always, -infinity to infinity. The domain is the vertical asymptote, which is 1 to infinity, because it's on the right. All right. All right, 4, natural log again. So we're now same thing, base E. So we're using these points. Those are our basic points that we start off with. All right, this negative out front is a vertical flip, which means we change the sign of the y's. This means we are moving down 1. All right, nothing is changing in this problem in terms of the horizontal asymptote, because there's nothing in here. Right, when this doesn't change left or right, that's when we keep the vertical asymptote at 0. Okay, so I start at 1, 0. All right, 1, 0 is here. All right, and when I do a vertical flip, nothing happens. When I do a vertical flip, nothing happens, but then I move down 1 and over there. All right, then I'm at E1, which is right about here. I do a vertical flip. I'm then at E -1. Then I move down 1. I'm there. And the graph is that. So my points are at 1, -1. And this point here is, what are we at? Flip. So that's at -2. What I do with E? Nothing happened with E, right? Nothing happened with X. So it's at E and -1, -1, -2. So E, -2. All right. The domain is the vertical asymptote, which is 0 to infinity. The range is -infinity to infinity. All right. Now we have log base 3. All right. So this means our points we're starting with are 1, 0, and 3, 1. Okay. Now for this one, we have something going on here, which set that equal to 0. That's -2. So we're going to move to the left 2, and we are moving down 2. There's no flipping at all. So this right here tells me I have to move my vertical asymptote. It was at 0. We're going to slide it to the left 2, and that's going to make it a vertical asymptote at x equals -2. All right, I'm going to take 1, 0. I'm going to move it to the left 2 and down 2. So it's at 1, -2. And then I'll be at 3, 1. I move that to the left 2, which is at 1, 1. And then down 2, and I'm right there. There's my graph. All right, so this was at 1, -2, and this point is at 1, -1. All right, the domain of this one is going to be -2 to infinity, and the range is always -infinity to infinity. All right, scroll down for the other ones. All right, so number 6, we have something we haven't seen yet on this homework. Okay, so a couple things actually we have here. We have log with nothing here. Okay, and this is the thing I don't think Ms. Bemke in her examples did any. I tried to put a little update on the classroom. Hopefully you guys saw it. If you didn't, no big deal. If there is no log written, okay, just like when there's no natural log, we assume it's e. For log, it is a base 10. The reason is because we have a base 10 number system. All right. Explain that to you more one day, but our number system is base 10, right? Ones, tens, hundreds, all that, right? Well, those are all the powers of tens. 10 to the 0, 10 to the first, 10 squared, 10 cubed, 10 to the fourth. That's our place value system, okay? So that's why if you don't see anything, it's base 10, which means that our points would be 1, 0, and the base, which is 10, 1. Now, for something like this, am I going to write out 10 hash marks on this? Absolutely not. Okay, you just need to label the points. In all these, you don't need to really put the hash marks. Sometimes it's easier to graph that way. So this negative is a vertical flip. This negative is a horizontal flip. Right, just like it meant for, and this means we're moving up 1. All right. Now, good news is nothing is changing. They got a negative flip here, but there's no slide. So the vertical asymptote is still going to be at 0. Okay. Now, vertical flip means you're flipping over the x-axis, which means you change the y-coordinate. Horizontal flip means you flip over the y-axis, which means you change the x-coordinate. So whenever in a log graph you do a horizontal flip, you're going to end up on the other side of the asymptote. So our graph is going to be over here somewhere. If it's not, we did something wrong. Okay. Remember, we do all flips first before we do the shifting up, down, left, and right. Okay. So I would normally be, I don't want to put that there. All right. So normally 1, 0, right? I would be around here. I would do a vertical flip, change the sign of the y. Nothing happens. Still at 1, 0. If I do a horizontal flip, I'm here at -1, 0. And then I can move up 1. So it's like right there. Like I said, don't really need the hash marks there, but because I'm just going to label it because I'm not going to put all this stuff for 10. All right. So I'm now at -1, 1. All right. I'm at -1, 1 because I changed the sign of the x to make it -1, added 1, -1, then moved the y up 1. So that's where we're at -1, 1. All right. So 10, 1. So 10, 1's like over here. When I do a vertical flip, I go to 10, -1. When I then do a horizontal flip, I then becomes at -10, -1. I then move up, and I'm at -10, 0. All right. And the graph normally looks like this. When it gets flipped vertically, it looks like this. Then horizontally, I have a graph that is going like that. All right. This point's easy to tell that it's negative. So that point is -1, 1. And my other point here is -10, 0. Range is -infinity to infinity. domain is going to be, it's on the left side now. So this is going to be negative infinity to whatever the vertical asymptote, which is 0. Okay. So just how we got negative 10, 0, it's 10 comma 1. We did a vertical flip, which means I changed the sign of my y. So I'm at 10, negative 1. Then I do a horizontal flip. I change the sign of my x. I'm at negative 10, negative 1. Then I move up 1. So I add 1 to the y. So that's why I'm at negative 10, 0. All right. So here back to base e. So that's 1 comma 0, e comma 1. All right. Set this equal to 0. And I get 2 to the right. Now, we also have a negative in front of the x. You can't forget about that, which means we also have a horizontal flip, which means we better be on the other side here. Okay. Okay. So our vertical asymptote, since this moved 2 to the right, means we are now at x equals 2. Our graph, since a horizontal flip, should be on this side. Let's say 1, 0. If I do a horizontal flip, it means I change the sign of the x's. I'm now at negative 1, 0. Move 2 to the right, I actually end up in the same spot I started at, 1, 0. E comma 1. All right, that's like right here, e comma 1. I flip it horizontally. It means I change the sign of that. I'm now at negative e comma 1. And then I move to the right, and I'm like right about there. All right, and the graph is going to look like that. And importantly, you got to label these points here. Okay, so this is obviously 1 comma 0. All right, that point there is 1 comma 0. This point here is, what did I do to the x? It's still at 1 because nothing happened to the y. I changed the sign of it. I flipped it, so it's negative e. I then added 2 comma 1. Right, negative e plus 2. All right, change the sign of it, and I added 2. So you don't have to write like negative 0.7 or 718. Just write negative e plus 2. So the domain is going to be negative infinity. It's on the left-hand side to whatever the vertical asymptote, which is 2. Range is always negative infinity to infinity. All right. All right. Once again, we have a base e, so we're using these points again. The only thing happening here, I'm moving to the left 2. That's it. All right, which means I have a vertical asymptote at x equals negative 2. All right, nothing else is happening at this problem. All right, so I'm at 1 comma 0. I just moved to the left 2. I'm at negative 1 comma 0. Remember, basic shape is this, so we're sliding it. It should be something like here. E comma 1 here. We're just going to move to the left 2, which is like right there. All right. So I have negative 1 comma 0, and I have e minus 2 comma 1. Those are my 2 points. The domains are now back on the right side. So it's whatever my vertical asymptote, which is negative 2 to infinity. Then the range, negative infinity to infinity. All right, 9, we're once again using base e, natural logs. We're using these points again. All right, so I have a vertical and a horizontal flip. That's it. Okay, so we're just going to be changing the signs of x's and y's. 1, 0, e1. Okay, the asymptote stays exactly the same. Okay, I'm normally at 1, 0. So I change the sign. So basically all you're doing is changing the signs of the x's and the y's. That's it. All right. So it's negative 1, 0. So I'm right here at negative 1, 0. E comma 1. I go to negative e, negative 1. Right there. And it looks like that. Notice I don't have any really hash marks there. So it's change the sign of both. It's negative e, negative 1. As long as it's labeled, I don't need to see anything. All right, and then 1, 0 is negative 1, 0. Okay. Domain is negative infinity to the vertical asymptote, which is 0. The range is negative infinity to infinity. All right, last one, base 10 again. So this is, why is it base 10? Because there's nothing there. So it's just like number 6, 1 comma 0, 10 comma 1. There's no negatives in front or negatives in x, so we're moving, set this equals 0, we're moving 1 to the right, and we're moving 2 up. Okay. So since I'm moving 1 to the right, all right, we have x equals 1, we have a vertical asymptote. All right, so 1, 0, I normally move that 1 to the right, which makes that 2, 0, up 2, which means that is at 2, 2. All right, so I have a point at 2, 2. 10, 1. I move that to the right, it's 11, 1. Move it up 2, it's at 11, 3. And that point is 11, 3. How'd I get that? 10, 1, move 1 to the right, adds 1 to the x, that's 11, 1. Move up 2, 1 plus 2 is 3. So 11, comma 3. All right, so the domain here is vertical asymptote is at 1 to infinity. The domain, once again, is negative infinity to infinity. All right, so that is that for graphing logs. Hopefully you guys, by the end of it, starting to figure it out. We will spend the next 2 days of class reviewing, and then your quiz will either be Monday for class 2. It's going to be Monday next week, May 11th. For class 4, yours will be on Tuesday, May 12th. All right. Hope everyone is doing well, hanging in there, and I'll talk to you guys soon.